Here's a second example where we'll be using the first derivative test, and let's find the relative extremum for f of x is equal to x to the 2/3. Well, first we need to find critical points, so we'll take a derivative, and that will be 2/3 x to the 2/3 minus 1, or 2/3 minus 3/3, which is negative 1/3. That would be equal to 2 over 3 times x to the 1/3, which is 2 over 3 times the cube root of x. Okay. All right, now notice that in this case this fraction will never be 0 because the numerator is 2, it will never be 0, but it'll be undefined when x is equal to 0. So x, maybe I should say it like this, f prime of 0 is undefined so x equals 0 is a critical point. Now notice in this case we couldn't use the second derivative if we wanted to, because the second derivative only works where the first derivative is 0, not where it's undefined. This one is undefined, so that can't happen. But we can use the first derivative test. So again, it's undefined at 0, so it could change signs at 0. But now let's see what happens with this. All right, if we look at this, all right, if we pick a number to the left of 0, say x is equal to negative 1. If I replace x with negative 1, I'd have the cube root of negative 1, which is negative 1. So this would turn out to be negative 2/3. It's negative, so we're decreasing here. All right, the function itself is decreasing. On the other side, say at x equals 1, well, the cube root of 1 is 1, so this would be positive 2/3, so we're increasing here. We're increasing here. So there is a relative min at 0. And now let's see, what is that relative min? The relative min is f of 0, and f of 0 is 0 to the 2/3, which is equal to 0. All right, this is a relative minimum, all right, located at x equals 0. All right, I think I have this worked out here in this next part here. All right, and here's the graph. Notice that there's the derivative is undefined because you see we have a cusp on it. Remember, derivatives are undefined, but we have a relative minimum. The height of it is 0, and it's located at 0. So here's an example, another example of using the first derivative test to find a relative max or minimum.